Let's take a look at product law. This is like the last law. We can say this is the last law involved in the law of indices. And product law states that when raising an expression, let's say a raised power x, having a power where x is the power to another power. Now when we are raising the whole expression to another power, the result will be the same base a and their powers multiplied, xy. So with this simple analogy, let's take few examples to clarify this. I was given 3 raised to the power 5 all raised to the power 3, or we can say 3 raised to the power 5 all raised to the power of 2. Now the expression itself is 3 raised to the power 5, and it is now being raised to another power of 2. Now from here we can say that the base is 3, and then the resultant of their product of their powers will be 5 multiplied by 2. That's 5 multiplied by 2, and this will give us 3 raised to the power of 10. Let's take another example. We're given y raised to the power 4 all raised to the power of 3. The entity or the expression we are considering is y raised to the power 4, and y raised to the power 4 itself is raised to the power of 3. So the result will be the same base and their powers be multiplied. So this will give us y raised to the power of 12. Let's take another example. We have m raised to the power of 2 over 3 all raised to the power of 6. Now this concept of power, which is called fractional indices or fractional index, okay, fractional index will be considered later in the course. Now the base remains the same, but the powers are being multiplied. So this will give us 2 over 3 multiplied by 6 will give us m raised to the power of 4. Let's take some more. A raised to the power of 0 all raised to the power of 2. Now this, as it is, we know that a raised to the power of 0 is 1. Okay, we can solve this in 2 ways. You know, mathematics is not one direction, it's multi-directional. We can solve it in many ways. Now let's solve this like this. A raised to the power of 0 is 1, and it is raised to the power of 2, and 1 raised to the power of 2 is what? Is still 1. Also, this can be resolved by saying, applying the law, the product law that we just considered, and say this is a raised to the power of 0 multiplied by 2, and anything multiplied by 0 is 0, and anything raised to the power of 0 is 1. Let's take one more example. 5 raised to the power of minus 3 all squared. Now 5 is the base and their powers are being multiplied, and this will give us 5 raised to the power of minus 6. Now to simplify this further, we can rewrite this to give us 1 divided by 5 raised to the power of 6. And 5 raised to the power of 6 is equal to 15625. We are given 3 into z squared raised to the power of 4. Now to avoid confusion, 3 into z squared can be written as 3 times z squared, and this entity or the expression z squared is being raised to the power of 4. Therefore, we simplify this expression first using product law and say this will give us z raised to the power of 2 multiplied by 4, and this will give us 3 multiplied by z raised to the power of 8, and this will give us 3 z raised to the power of 8. Now, in the same vein, what if we have 3z squared raised to the power of 4? Now we can see that in the previous question, z3 was not included in brackets, but here we can see 3 is being coupled as an entity to be considered in the bracket. Now in this place we have 3 multiplied by z squared raised to the power of 4. Now to take us further in this question, we'll understand that an extension of the product law says that AB raised to the power of x will be equals to a raised to the power of x multiplied by b raised to the power of x. Or we can simply say that AB raised to the power of x is equals to a raised to the power of x, b raised to the power of x. Now in this case, we have 3 to be our a and z squared to be our b. Therefore, we can say this is 3 raised to the power of 4 multiplied by z squared raised to the power of 4. Therefore, we can now simplify, and 3 raised to the power of 4 is 81, and z squared raised to the power of 4 is with z raised to the power 2 times 4, and this will give us 81 multiplied by z raised to the power 8, and this will give us 81 z raised to the power 8. Now we can see from this expression that 3z squared raised to the power of 4 is not equal to 3z squared all raised to the power of 4. Now in our next video, we will take more examples on product law so that we understand how they are being structured and the diversity of product law.